Before you, you can see three formulas that you're expected to be familiar with and be able to use. So the first one we can see here is speed. Speed is distance divided by time. Now, some people find it easier to work with these formulas if they use them in this triangular fashion that you can see here. So we've got S for speed, D for distance, T for time, and I'll do an example in a minute and we'll go through how to use that triangle. But just to give you a tip in remembering what the formula is in the first place, the most common way that we talk about speed would be in miles per hour. So think about it. Miles is a form of distance, hours is time, and the per gives you the fact that it should be divided. So that can help you to figure out or remember what that formula for speed should be. So the next one that we can see here is density, which is mass divided by volume. And again, because it's got those three parts, we can just use a triangle to help us work out what we need in a given situation. And again, the units that we might be given for density can help us to work out or remember what this formula is. So typically the units are either going to be grams per centimetres cubed or kilograms per metre cubed. So you can see that on this side we've got weight or mass, and cubed implies that we are dealing with a volume here. So the third formula is pressure. That's force, which is measured in newtons over area, and again that can be put into one of these triangles. So this first question says, if a runner covers 3 kilometres in 15 minutes, what was their average speed in kilometres per hour? So the triangle that we're going to draw for this one has the speed here, and then it's the distance divided by the time. So how do we use this to help us write down the formula? We cover up the one that we're looking for, which in this case is the speed. I'm shading it because I can't cover it for you. And so that tells us that the speed is equal to the distance over the time. So in our particular example, our distance is 3 kilometres and our time is 15 minutes. However, they've asked for the speed in kilometres per hour. So instead of writing the time in minutes, we need to write it in hours. So that would be 3 kilometres over a quarter of an hour, so 0.25 of an hour. I'm going to lose the units now that we've got those correct. So remember that if you've got a bottom like this that's a decimal, then to get out of trouble we multiply it by 10 or 100 to make it into a whole number so that we can work with it. This is assuming you're not allowed to actually use a calculator in this question. So in this case, multiplying the top and the bottom by 100 will give us 300 on the top, 25 on the bottom, and 25s into 300. There's 4 in every 100, so there will be 12 in 300. So our speed is 12 kilometres per hour. In this next question, we're told that the density of steel is 8,050 kilograms per metre cubed. And we're asked to find out what the weight of a 2 centimetre cube of steel would be in grams. So here's our triangle. Density there, mass here, and volume here. So this time we're looking for the weight, which is the mass. So I'll cover that one over. So that means that the mass will be equal to the density multiplied by the volume, because they're on the same level. Now we want the weight in grams at the end, but notice the density is given in kilograms and in meters cubed, and our measurements in centimeters, and we want it in grams, so we need to do some transformations here. So our density at the moment is 8,050 kilograms per meter cubed. So the first thing we're going to deal with is going from kilograms to grams. So there is 1,000 in each kilogram, so that means that this would be the same as 8,050,000 grams per meter cubed. Now we need to change the meter cubed element into centimeters cubed. So 1 meter cubed is the same as 100 times 100 times 100, which is 1 million centimeters cubed. Now we need to divide by that because the volume is a division aspect, not a multiplication aspect. And so the density will be 8.05 grams per centimeters cubed. So now we've got the density in the right units, we also need to get our volume. So in this case we've got a 2 centimeter cubed, so it's going to be 2 by 2 by 2, so that means it's going to be 8 centimeters cubed. Now we've got everything in the right units, we can just do the sum. So the mass, or the weight of this, is going to be 8.05 times by 8. That works out to be 64.4 grams. In our final example, we're told that a box exerts a force of 20 newtons on a table. The area of the base of the box that's in contact with the table is 40 centimeters squared, and we want to know what the pressure is in newtons per meter squared. So we need the pressure triangle this time. We've been asked to work out the pressure, so that's what I'm covering up. So our pressure equals force over area. So notice that our answer is in newtons per meter squared. So our force is fine because that's in newtons, but our area is in centimeters squared and we need it to be in meters squared. So we need to change that. So 40 centimeters squared, we need to change that. So 1 meter squared equals 100 times 100 centimeters squared, which is 10,000 centimeters squared. So in meters squared, we need to divide the 40 by the 10,000 to get that. Probably easier to see and understand if we do it this way, so we can always write these divisions as fractions. Then we can divide top and bottom by 10, so what we're left with is 4 thousandths with a th on the end. So in decimal form that will be 0. That's the tenths, that's the hundredths, so that is where we're going to put the 4 because it needs to be in the thousandths column. So that's now meters squared. So now we've got everything right. So our pressure is going to be the 20 newtons divided by 0.004. So again, we can use the similar trick to before. To get 4 on the bottom, we'd need to multiply by 1,000. So on the top, we'd multiply by 1,000. So that leads us to this sum. And then that will give us an answer of 5,000 newtons per meters squared.